Hi everyone, let's do definite integral today. I'm going to do 10 questions with you. If you're able to do these 10 questions with me, you will be able to handle the rest of the questions on your own. Now the first question is evaluate 0 to pi x sine x upon 1 plus cos square x dx. Forget the limits, forget x. If the question is sine x upon 1 plus cos square x, how do you integrate this? The first method of integration, that is substitution. Substitution should come to your mind that if you put cos x is equals to t, you will be able to handle this because the derivative will be sin x dx is equals to dt. You will make the question as dt upon 1 plus t square and the integral is tan inverse t. The question is done. But now we have x over here. Whenever in such cases that you're not able to apply substitution or you're not able to integrate and we have x over here, you can use the property of definite integral. Now what's the property? I'm writing the property over here, that is 0 to a fx dx is equals to 0 to a f of a minus x dx. It means wherever we have x in the function, in place of x you're going to use a minus x. What is a? A is the upper limit. Now we have x in this question, and one more thing, this property is applied when there is a function and we have something in the denominator. This property is applied when after applying the property the denominator remains the same. Over here, have a look over here. If I apply the property over here, means wherever I have x over here, here and here. In place of x, just put a minus x. What is a over here? Upper limit pi. So pi minus x, pi minus x and pi minus x. Now see what happens. When you apply the property over here, pi minus x, this is as it is, pi minus x, sine pi minus x, second quadrants, it will be sine x, cos pi minus x, cos 180 minus theta lies in the second quadrant. In the second quadrant cos is negative, but I have square over here, so this will become cos square x. So see, my denominator remains the same after applying the property. That's the denominator here, that's here. So you only apply the property when the denominator remains the same. I have applied the property. Whenever you apply this property, you do add the equation. This is equation number 1, means before applying the property, you take the integral as I, and this is after applying the property. This is equation number 2. You always add these two equations. The left hand side will become 2i, I plus I, and in right hand side, open this bracket, take the LCM, and when you open the bracket, when you will take the LCM, you are left with x sin x. I'm writing that step over here. Just understand it once, and rest of the questions you will be able to handle. From equation 1, the numerator is x sin x, and from equation 2, the numerator is, open the bracket, pi sin x minus x sin x, and the denominator was same, so I have taken the denominator as well. So x sin x and x sin x will get cancelled. You're only left with pi, so you have actually get rid of x. Now the question is very simple. As I've told you, you will substitute it, cos x equals to t, sin x dx is equal to dt, and you will get it as dt upon 1 plus t square. I have done it over here. Now I'm just telling you how to change the limits once, and rest of the questions you can handle on your own. How do we change the limits? Whenever you substitute, you do change the limit. So your substitution was cos x is equals to t. That was the substitution. Now what is the lower limit in the question? The lower limit was 0. So when x is equals to 0, t will be cos 0. What is cos 0? That is 1. Means the lower limit will become 1. And when x is equals to pi, so t will become cos pi. Cos pi is minus 1, so the upper limit will become minus 1. And we have done the integral over here, dt upon 1 plus t square, that is tan inverse t, that is, sorry, it is t over here, that is tan inverse t. So, and the limit is from 1 to minus 1. Put the limit over here, upper limit minus lower limit, it is minus pi by 2, upper limit is tan inverse of minus 1, and lower limit is tan inverse of 1. That is the lower limit. What is tan inverse of 1? That is pi by 4. So minus pi by 4, minus pi by 4, and there's one more negative sign, so it will become pi square upon 4. Now let's do the next question. Question number 2. 0 to pi x tan x upon sec x cos x. Now whenever there's a question which is with sec x, with cosec x, usually you change into sine and cos. So let's change into sine and cos. After changing into sine and cos, it will become x sine square x. Now if the Question is sine square x. I hope you will be able to integrate it whenever there is square, whenever there is cube, sine cube x, cos square x, sine raised to power 4x, cos raised to power 4x. All these questions are done with using the identity, and you use the formula for cos 2x. The formula for cos 2x is 1 minus 2 sine square x. From here you will get sine square x as 1 minus cos 2x upon 2. So you will use sine square x as 1 minus cos 2x upon 2, but this you will do later after getting rid of this x. How to get rid of this x? Again the same thing. Apply the property. In place of x, just write pi minus x. Wherever there is x in the function, just write pi minus x. And sine 180 minus theta, sine 180 minus theta is the second quadrant, that is sine theta. So this is sine x over here. Now this is equation number 1, means the question after simplifying, right? And this is equation number 2 after applying the property. Add equation 1 and 2. When you will open the bracket, x terms will get cancelled. You're only left with pi 0 to pi sine square x. Now sine square x, how to integrate? It will be 1 minus cos 2x upon 2. Now do the integral. Integral of 1 is x. Integral of sine cos 2x will be sine 2x. Don't forget to differentiate 2x, because this is not x, this is 2x. So that 2 after chain rule you have to write over here, and then apply the limits. As I told you earlier, over here you will apply the limit from 0 to pi, and the question will be done after applying the limits. Now moving to the next question, that is question number 3. Important question, NCERT question, 0 to pi by 2 x sine x cos x upon sine raised to power 4x plus cos raised to power 4x. Now whenever you have cos square x in the denominator, right, you divide by cos square. Now we do not have cos square x, we have cos raised to power 4x over here. So we can divide the numerator and denominator by cos raised to power 4x. We will do it later because we have x over here. So this is giving you the hint that whenever we have x over here and you want to get rid of this x, you are not able to substitute, and this x is creating a problem. Apply that property, get rid of that x. So I'm applying the property, and see, my denominator will not change after applying the property, because sine 90 minus theta will become cos theta, cos 90 minus theta will become sine theta. Let's apply the property. Here, wherever there is x, applied the property. Cos 90 minus theta has become sine theta, and sine 90 minus theta has become cos theta. Applied the property. This is equation number 2. The question was equation number 1. Adding equation 1 and 2, you will get rid of x again, and pi upon 2 you can take common over here. Outside, I mean, that's a constant. So 0 to pi by 2 sine x cos x upon this. Now how to integrate this? Make sure you divide by cos raised to power 4x. So let's divide by cos raised to power 4x over here. Cos raised to power 4x, cos raised to power 4x, and the numerator also cos raised to power 4x. Now this will become 1. So this is 1 over here. Sine upon cos is tan. Now this sine, this is cos raised to power 4. So cancel one of the cos. You are left with sine in the numerator. You are left with sine upon cos cube x. So it means sine upon cos x into 1 upon cos square x. So this has become tan over here, and this has become secant square x. Now what to do now? You can do in two ways. Either you can put tan x equals to t, better you put tan x equals to t, or you can also put tan square x equals to t. So when you're going to put tan square x equals to t, you differentiate. So that is 2 tan x into secant square x dx, that is the numerator. So entire numerator has become dt, and the denominator as 1 plus t square. Make sure you change the limits. So when you're changing the limit, when x is 0, so tan 0 is 0. So the lower limit will be 0. And when x is pi by 2, so what is tan of pi by 2? Tan of pi by 2 is not defined, that is infinity. So the upper limit will be infinity. Integration of 1 plus t square is tan inverse t. Apply the limits and you will get the answer. Moving to the next question. Now question number 4. Question number 4 in NCERT, this question is given in 2-3 ways, and there is a trick which has to be applied in this question. I'm reading out the question for you. Evaluate 0 to pi by 4 sine x plus cos x upon 16 plus 9 sine 2x. Now whenever the numerator is sine x plus cos x and the denominator is sine 2x, right, you have to make the substitution as sine x minus cos x equals to t. This you have to remember how you should approach this. See, when you will put sin x minus cos x equals to t, though sin x minus cos x is not given anywhere in the question, but when I'll put this as t, I will get the numerator as the derivative of sin is cos, so cos x, derivative of cos is minus sine, so this is plus sin x, dx is equals to dt. So in such questions you have to think that what should I substitute so that I should get this as the derivative. So somewhere you integrate it, right? Because the derivative is the integral, right? And when you integrate you get the derivative. So somewhere you integrate in your mind, and that should be the substitution. So this should be the substitution, but this is nowhere given in the question. So when I go to the question back, so how to make use of the substitution? So I am going to do squaring both sides of my substitution. So I'm going to do this whole square is equal to t square. Now what is my left hand side? Means sin x minus cos x. I'm doing the squaring both sides. Let's do the squaring. So this is a square plus b square minus 2ab minus 2ab is equals to t square. So this is 1 and this is sin 2x. So 1 minus sin 2x is equals to t square. So this substitution you will only make in the question in which you have sin 2x in the denominator, because somewhere you're getting the value of sin 2x. So what is sin 2x? Sin 2x is 1 minus t square. So that denominator 1 sin 2x has become 1 minus t square. The entire numerator has become dt, and rest of the question as it is. So this is very important, but there is a trick apply over here. You have to apply your intelligence that what you should substitute that you should get the numerator as the derivative. And when you do the squaring both sides, then only you will get you will be able to apply the value of sin 2x. So sin 2x has become 1 minus t square and the numerator has become dt. You can also change the limits. I've told you how to change the limits. You can do that. Now coming to this has become 25 minus 9t square. So somewhere you can apply the formula for 1 minus a square minus x square, because 25 is a constant, right? So you can divide it, you can take common 9 over here. So this will become 5 upon 3 square minus t square. I always do this step because students usually do not apply chain rule later. They forget to write t in the denominator. So make sure the coefficient of t square you make as 1, so that you shouldn't do that error later. So you can apply the formula for 1 minus a square minus x square, the integral of a square minus a square x square, sorry, that is 1 upon 2a log a plus x upon a minus x. So this is a plus x upon a minus x. Put the limits, you will get the answer. Right, another similar question. See, it's the similar. Over here, the question number 4, that's 0 to pi by 4 sin x plus cos x, and the denominator somewhere they're having sin 2x. Another same question. Now the limit is not from 0 to something. The limit is from pi by 6 to pi by 3, and again we are having the same thing. We are having sin x cos x, and in the denominator we are having sin 2x. So as I told you, whenever you have sin 2x in the denominator, over here we are having inside the root. In the previous question, we were not having inside the root. And one more thing I just forgot to tell you in this question number 4, that if you apply 0 to a property over here, you will not get anything substantial over here. So that property is not going to work here. So that is why we have not applied that property over here. So and we have done the substitution sin x minus cos x. So in this question also the same thing, the same concept will be applied. You are going to put sin x minus cos x equals to t. When you will differentiate, you will get the numerator. The numerator will become dt. Just a minute, my cursor is not moving. Yeah, let me. All right, here. You won't be able to see the screen. So what you will get after, let me write over here. After the substitution, numerator you can write as dt, and the denominator will become 1 minus t square, because I have already told you in the previous question that sin 2x will become 1 minus t square and the numerator will become dt. And limits you have to change. Limits in this question, limits changing are little lengthy, because the substitution was sin x minus cos x is equal to t. So when you change the limit, when x is equals to pi by 6, So this will become sine pi by 6 minus cos pi by 6. That is t. So what is sine 30? Pardon me. What is sine 30? Sine 30 is 1 by 2 minus root 3 by 2. So the limits are a little lengthy but very easy, not difficult. So 1 by 2 minus root 3 by 2. So that will be the upper limit. Similarly, you will get the lower limit. You will apply the limits and you will get the answer. I'm also going to paste this worksheet in the Telegram so that you can have a look at the questions later. All right, now coming to the next question, that is question number 6. Reading out the question for you, 0 to pi by 2 under root tan x plus under root cot x is equals to under root 2 into pi by 2. You have to prove this. Now, again, if you apply the property a minus x, if you're thinking, you won't be able to get anything because you will get tan pi by 4 minus x. That is not going to become cot or something like that. Tan pi by 4, you'll be stuck. So let's not apply that property. Let's change it into sine and cos. Let's do that. So we are going to change into sine upon cos. So tan will be sine upon cos. Cot will be cos upon sine. Take the LCM. We have taken the LCM. Now after the LCM, again the same thing. So I've just shown you variety of the questions which are based on these questions, and the questions are NCERT based and are asked many a times in the exam. So make sure you do these questions. I hope you will be able to handle the question after this, because we have already done 2 questions based on this concept, right? So you can see in the worksheet and you can try the questions on your own. Now this question is also very, very important. Let me take this question. This is 7th question, important question. Limits are from pi by 6 to pi by 3. The question is dx upon under root 1 plus cot x. Now we do not have limit from 0 to something, so right now you cannot apply the property, but let's see how you can do that. So first of all, I've changed into sine and cos. So cot as cos upon sine, take the LCM. That is done. Now whenever we have sine x over here and the denominator is sine x plus cos x, look at the limits. This is pi upon 6 and this is pi by 3, means 30 and 60 degree, right? So there is one property given to you that when it is a to b fx dx, you can apply the property. This is f a plus b minus x dx, because when you add both of these, this will become 90, and so you can add both the limits over here and then minus x. So this has become 90, so I can apply the property. So it will become 90 minus x in the numerator and 90 minus x over here and over here also. Sine 90 minus theta is cos theta. I have applied the property, and after applying the property, look, this is equation 1 and this is equation 2. After applying the property, my denominator remains the same. That is why I have applied the property. So this question is very, very important and is asked in board exams also many a time. So make sure you do this. So we have applied this limit very nicely. They have applied the limit and my denominator the same. Now I can add these, and when you add these, this will be cancelled. You're only getting one. Integral of 1 is x. Apply the limits and you will get the answer as pi upon 12. So NCERT question. Okay, now moving on to the next question. Next question is minus a to a under root of a minus x and a plus x. Now whenever there is a limit from minus a to a, so you should know the property minus a to a fx dx is equals to, this is equals to 0, and this is either it will become 0 or it will become 0 to a f of x dx twice. This will be 0 when it is an odd function. This will be twice of this when this is an even function. What is odd? Odd means f of minus x is equals to minus of fx. What is even means f of minus x is equals to fx. Now that you have to check. So I will check this, but let me just here. Okay, so let me just rationalize and see what kind of functions I'm getting and whether this is an easy function to integrate or not. I have just done the rationalizing part. So it was plus over here, so I've done with a negative sign. So this is a minus x upon a square minus x square. So you can separate it now. So a square a upon under root a square minus x square and x upon under root a square minus x square. Now the first integral over here, this is simply the formula for under root a square minus x square. So if you know the formula, this is the formula for sine inverse x upon a. So my first integral is not a problem. First integral is done. Now coming to the second integral. Second integral, you can check whether the second integral, so I am checking my second integral. So when I'm checking my second integral over here, see, I have written the second integral over here. I have written the second integral over here. Now this is the function, this is the function, this whole is the function. How you check even and odd? You put in place of x, you put minus x. So I'm putting minus x wherever there is x, it is over here and here. The denominator over here, this is a square, so that will remain positive, and I'm getting one negative sign in the numerator. It means this has become minus of fx, and I have told you when it is f of minus x is equals to minus of fx. See, let me show you this. When it is minus, when you're getting negative sign outside, it is an odd function and you do not have to integrate. The integral will be 0. That's a property. So you can apply the property for the second integral. For the second integral, that's an odd function. This is an odd function. You do not have to integrate. So this will be 0. Only you have to integrate that, and that will be the final answer. So that is the integral of this is 0. And this is the first integral, and you're getting the answer as a pi. This is one of the board question. You can see the question, and then I have explained you can do it on your own, and you can see whether you're getting the answer as a pi or not. Now moving to question number 9. Question number 9 is actually a little lengthy, but something very simple question. That is 2 to 5 modulus of x minus 2 plus modulus of x minus 3 and then x minus 5. And CBSE asks these types of questions many a times. So what do we have to do? See, whenever you have modulus, make sure you know the property of modulus, that it will be positive. It will have either modulus. Let me tell you the formula. Modulus is positive when x is greater than or equals to 0. It is negative when x is less than 0. That is the definition of modulus. That is the definition of modulus function. Now we are not having only modulus x, we are having x minus 2. I'm just explaining you for one. Modulus of x minus 2 will be either it will be positive or it will be negative. Positive when x is greater than or equals to 2. Negative negative when x is less than 2, right? Now this is positive when x is greater than 2, negative when x is less than 2. Similarly for x minus 3 and x minus 3, I have explained you over here. Now this function is changing at 2. You can see it's changing at 2, getting a negative or a positive value. It's changing at 3. You can see 3 over here. It's changing at 5. Means whatever you have inside the modulus, just put it equal to 0. It is changing at 3. X equals to 3. It means it is changing at 3. It is changing at 2 and 5. 2 and 5, it's already mentioned in the question. It means you have to write 3 also in the middle. It means the whole integral was given to you as 2 to 5. It means this integral function, just write over here function. It means this integral can be written as 2 to 3 plus 3 to 5, and keep on writing the functions over here. Keep on writing the functions over here. It means it is changing at 3 also. So this integral you have divided into two integrals, that is 2 to 3 and 3 to 5. Now 2 to 3, when it is from 2 to 3, let's see the signs. So when it is from 2 to 3, when it is from first integral 2 to 3, when it is from 2 to 3 means less than 3 and greater than 2. So x minus 2 will be positive because this is less than 3, right, and greater than 2. So this will be positive. Now x minus 3 less than 3. So x minus 3, I'm just giving you one example over here. X minus 3 will be positive, will be negative, will be positive when x is greater than or equal to 3, will be negative when x is less than 3. So the limit is from 0, from 2 to 3. It means it is less than 3. It means it will be negative. So this modulus will be negative. So it is minus of x minus 3, means I have just written it as 3 minus x. So this will be negative. x minus 5 will be also negative when it is from 2 to 3, because x minus 5 will be negative when it is less than 5. So it is only till 3, means it is less than 5. So of course it will be negative. So this will be negative, this will be negative, but this one is positive. So this is positive, negative, negative. So just simplify it. X and x will be cancelled. So just simplify, put the limits, integrate, and you will get the answer. Similarly, then you have to write the positive and the negative sign for this integral also from 3 to 5. So when it is from 3 to 5, this integral will be positive, right? Because this is both the upper and the lower limit, both it is greater than 2, right? So this will be positive, this will be also positive, but this one will be negative. This one will be negative because it is less than 5. So positive here, I have written positive here. This one is negative, so written as 5 minus x. So simplifying, x and x will be cancelled, simplifying, and minus 2 minus 3 5. So you're getting x square upon 2, integrate, and then add both the integrals. Just have a look here, add both the integrals. Okay, we divided the integrals into two. The first integral from 2 to 3, other integral from 3 to 5, and then putting the signs and then integrating. So you will do the whole question. The answer you're getting as 23 upon 2. So make sure you integrate on your own. Now let's do the last question. The last question is from 0 to 3 by 2, x sine pi x. Very, very important question. NCERT solved question is asked in board question, and when they give the question, they put it in the category of HOTS. So the thing is, it is from 0 to 3 by 2 x sine x. Now this x sine x will either be a positive or a negative. So let me explain you that. So x sine x. So what I'm doing, I'm just seeing where it will change the sign, right? So I'm putting it equal to 0. So either x is equal to 0 or sine pi x is equal to 0. So when sine pi x is equal to 0, means x is equals to, it is at sine 0, is this is sine pi is also 0, sine 2 pi is also 0. I hope you're understanding that. So when this is equals to this, I'm getting x as 0, because pi x equal to 0 means x equal to 0, which is already there. When I'm putting the first one and this as 0, so sine pi x is equals to sine pi means x is equals to 1, and from here I'm getting x equals to 2. So that is not required. You only have to see from 0 to 3 by 2. It means this whole integral will be divided into 0 to 1, because it is also changing at 1, because you're getting the value at 1 from 0 to 1 plus 1 to 3 by 2. First of all, you should know the intervals, right? So 0 to 1 and 1 to 3 by 2. Now how to write the positive and negative signs? Now positive and negative sign, just understand this is something little very interesting also. So I am having x sine pi x. Now 0 to 1, x will be always positive. From 0 to 1, whichever number you take, it will be positive. Now what about this sign pi x? When x is from 0 to 1, means pi x is from 0 to pi, I'm multiplying by pi, it means they're talking about the first and second quadrant. So in first and second quadrant, sign is positive, so this is positive. So x sine pi x will be positive. So this is x sine pi x with the positive sign, Now when it is from 1 to 3 by 2, now it is from, I'm erasing this, when it is from 1 to 3 by 2. So 1 to 3 by 2, x will be positive, and I have to check this now whether this will be positive or not. So when x is from 1 to 3 by 2, means pi x, I'm multiplying by pi, it will be from pi to 3 pi by 2. What do you mean by pi to 3 pi by 2? Pi to 3 pi by 2 means the third quadrant. In the third quadrant, sign is negative, so this is negative. So plus minus minus, so this one will be negative. So this is x sine pi x dx. Don't mind the handwriting, please. So this one will be positive from 0 to 1, and this one will be negative. Now how to integrate this? This you will integrate by parts. How? First function into integral of second function. right? I hope you will be able to handle on your own. So first function into integral of second minus differential of the first one, integral of second, and then integrate the whole thing, apply the limits, you will get the answer. So I'm going to put this whole worksheet, not the worksheet, all the sets of the questions in the link, and I hope you will be able to do the questions on your own. I have explained you these important questions. That's all for